from Public School. Now I am going to continue your science chapter, that is atoms and molecules. Now this is the last part of this chapter. What I have written on this, the molecular mass and the mole concept. And before going to this one, in the previous sessions, in the previous classes, what we discussed about the atomic masses. Once again I am going to recall the atomic mass. Afterwards we move on to this one, molecular mass. And you know that atomic mass, okay, the total number of protons and the neutrons in an atom, or else in other words, the mass of an atom, that we already discussed in the previous classes. Like that, now again we are moving to the molecular mass. What is that molecular mass? The sum of the atomic masses of all atoms present in a molecule of a substance, right? That we call it as molecular mass. The word itself indicates molecule. What is that molecule? You know that the combination of or a group of atoms that combine to form a molecule. We are going to calculate the mass of that molecule. In other words, the sum of the atomic masses of the atoms that are present in a molecule, that gives you the molecular mass, right? For example, I am going to write some chemical name. You will get the concept of that molecular mass. Now I am going to write you here the HNO3. You know that what is this chemical? Nitric acid, HNO3. Hydrogen, nitrogen and the oxygen. And one more, I am going to show you that I have written a symbol U. This U indicates the molecular mass, right? Now I am going to calculate the molecular mass of this nitric acid. Here, what I said in the definition, sum of atomic masses of all the atoms that are present in a molecule of a substance. I am going to consider one molecule of this nitric acid. Now I am going to calculate the molecular mass. I am going to write here U equals, what is the atomic mass of the hydrogen? 1. And how many atoms are there? Only 1. 1 hydrogen plus the nitrogen. Only 1 nitrogen atom is there. We know that the atomic mass of the nitrogen is 14. And oxygen, we know that the atomic mass of the oxygen is 16. But 3 atoms of the oxygen are present in this molecule. For that reason, I am going to write 3 into. What is the atomic mass of the oxygen? 16. Now, you add all these things, you will get the molecular mass of this nitric acid. Now, I am going to add 1 plus 14 plus 3 into 16, that will give 48. Right, I am going to add now. U equals 48 plus 14 plus 1. Right, 48 plus 14, 62 plus 1 will get 63. U equals to 63. This is the molecular mass of the nitric acid. Like that, you are going to calculate the molecular mass of all type of chemicals by counting, by considering the total number of atoms of that particular element. Then you will get the molecular mass. Then along with that, one more I have written unit mass. What is this unit mass? Again, this is very similar kind. This is very similar to the molecular mass. Now I am going to continue this one by taking the unit mass. Again, unit mass is also the sum of atomic mass of all atoms present in a mole or present in a molecule. Then I am going to consider a molecule. Then I am going to calculate the unit mass by adding all the atomic masses. But the difference between the molecular mass and this unit mass is, to calculate any unit mass of a chemical, the atoms, okay, that are present in the form of ions, nothing but ions are present on that chemical. For example, I am going to take a chemical called NaCl. You know that sodium chloride. We know that sodium is a positively charged ion and the chlorine is the negatively charged ion. I am going to calculate the unit mass of this sodium chloride, because what I said, the difference between the molecular mass and the unit mass is that the ions are present on that particular compound or a chemical. I am going to calculate, again you are going to calculate the unit mass like this. Now I will write how many atoms are present here. The sodium, only one. How many atoms are present in the chlorine? Only one. And we know that the atomic mass of the sodium is 23 and only one atom is there. Take it as a like this, 1 into 23 plus, and how many atoms are there in chlorine? Only one atom. And what is the atomic mass of the chlorine? 35.5. The atomic mass of the sodium and chlorine and some different elements, they are given in the textbook table. You are going to refer that, you will get the atomic mass values. Then 1 into 23 you will get 23. Then 1 into 35.5 you will get the 35.5. Then by adding these two you will get the unit mass of the sodium chloride. Then what is the value? 35 plus 23, right? 58.5. This is the unit mass of the sodium chloride. Like that, again you are going to calculate the unit mass for different compounds. Then you can do the similar unit mass for calcium chloride. They are given in the textbook. Then you calculate this unit mass for the compound calcium chloride. Take it as a homework, right? Then again in the similar fashion you can calculate the molecular mass for H2O like this. I have taken the nitric acid and the sodium chloride, and you have to do H2O molecular to calculate the molecular mass for H2O, and you are going to calculate the unit mass for calcium chloride. You have to take these two as homework, right? Then after all these things, then I am going to move on to the new one, mole concept. What is that mole and what is the concept behind this mole? Then now we are going to discuss this mole by taking some different examples, right? Before going to understand the mole concept, we have to know thoroughly what is that mole, right? We know that atom is nothing but an indivisible particle of a substance. Then molecule, grouping, or a combination of two or more atoms, then that will give the molecule. Then what about the mole? Mole is nothing but it is the group of atoms, or nothing but the number of atoms or number of molecules or number of particles present in a chemical substance, present in an element, present in a compound. How many number of atoms, how many number of molecules, how many number of particles that are present in a chemical substance or in an element or in a compound. Then that concept or that we are going to describe by using a word called mole. Mole, M-O-L-E. Then we are going to use SI unit for this mole like this, M-O-L. We can consider and we can use this mole for all kind of chemical substances. Now I have written some example to understand this mole concept. Just look at here. 2H2 plus O2, that will give 2H2O. Nothing but two molecules of the hydrogen, then that reacts with the two atoms, right? Or one molecule. Look at here H2 is nothing but one molecule of hydrogen, like that O2 is the one molecule of oxygen. But here two molecules of the hydrogen reacts with one molecule of the oxygen, right? That gives two molecules of the H2 or nothing but the water molecule. By taking this example, I can explain. Now we are going to understand what is that mole. Now look at here, I have written some points over here. Two molecules of the hydrogen. What I said? Two molecules of the hydrogen. Because here two molecules are present. Then combine with one molecule of the oxygen. Here only one. Two molecules of the hydrogen combines or reacts with one molecule of the oxygen to form or nothing but it gives two molecules of water or two molecules of the H2O. This is first point. Then the second one, for U, we know that what is this U? U is nothing but the molecular mass. Then here we know that the atomic mass of the hydrogen is 1. Here two atoms are there, hence 1 into 2 is 2. Then two molecules are there, 2 into 2 is 4. For that reason 4U is nothing but the molecular mass of the hydrogen is 4. Combined with 32U, we know that the atomic mass of the oxygen is 16. Here two atoms are there, 16 into 2 is 32. For that reason 32U, nothing but 32 atomic mass of oxygen, right? To form 36U is nothing but H2O. We know that what is the atomic mass of the hydrogen is 1. Here two atoms are there, hence 1 into 2. Then two molecules are present, again 2 into 2 is 4 plus 16, right? We know that the atomic mass of the oxygen is 16 and two molecules of the oxygen is there, hence that become 2 into 16, 32. Then that will give 36, nothing but atomic mass of the water is 36. Now I am going to explain how we got all these. Now simply I am going to write. Now look at here, 2H2 is nothing but, now look at here, two molecules. 2 indicates the number of molecules, two molecules, and here there are two atoms. Two atoms are present. We know that the atomic mass of the hydrogen is 1, and here two atoms are there, hence that become 2. 2 into 2, that become 4. Then here consider this one, oxygen O2. We know that how many molecules are there? Only 1. There is no number behind this one. For that reason you have to take only one molecule. Then we know that the atomic mass of the oxygen is 16. Then how many atoms are there? 2 atoms are there. Hence I am going to take this one. 16 into 2 equals 32. Then 2H2O. 2H2O. How many molecules are there? 2 molecules. For that reason it has 2, and we know that the atomic mass of the hydrogen is 1. But here how many atoms are there? 2 atoms are there. Hence that become 2. Then plus oxygen. How many atoms are there? Only 1 atom is there. Hence the atomic mass of the oxygen is 16. Now 2 plus 16, that gives 18. 18 into 2, that will give 36. Like that they have taken this one. Now I am going to explain the second point again. 4U, how we got 4U means like this. 2H2 is nothing but 4U. 4U is nothing but 4 atomic mass. Then what is that? 32U. 32U is nothing but 32 atomic mass of the oxygen. Now how we got 16 into 2, 32. Then the 4 atomic mass combines with the 32 atomic mass of the oxygen, that will give 36U, 36 atomic mass of the water. That is your water, 36. Like that, we got an chemical equation. Nothing but this is hydrogen reacts with the oxygen, that will give the water molecule. Here, what we are going to understand is nothing but how many molecules are going to react. Then, what is the atomic mass of those molecules? Now, for example, here by looking at this example, what we are going to understand, the quantity of that substance or the quantity of the chemical substance characterized by, we are going to identify that particular chemical substance or a compound or that particular object, right, based on the number of molecules. Then by taking any chemical reaction, now this is a chemical reaction, by looking at this chemical reaction, how many atoms or how many molecules they are directly combining, they are directly involving in the reaction and producing this amount of or this number of molecules. The difference between the quantity of a substance and how many number of atoms or molecules are directly involving in a chemical reaction is that by taking these two parameters like quantity and the number of molecules, it is very convenient, it is very easy to describe, it is very easy to understand, right, by taking this concept mole. Nothing but, for example, I am going to consider one molecule, suppose one molecule, then how many number of atoms are there in that particular molecule, how many number of particles are there present in that molecule. A scientist called Avogadro, and you know that, I think already you know that, Avogadro, he found a number, experimentally he got a value, and for that reason we are describing by using his name Avogadro number. Then in textbook they are given Na. Okay, you take anything, Avogadro constant, in other words they are going to describe by this value like a Avogadro constant. In any molecule, you take any substance, you take any matter, it may be solid, liquid or gaseous, you take any molecule, the number of particles that are present in a single molecule, he got a value 6.022 into 10 power 23 particles or atoms or molecules. He got this value. For that reason, we are taking Na is nothing but Avogadro constant or Avogadro number, both are same. This Avogadro number indicates that the number of particles or number of atoms or number of molecules that are present in any substance, in any matter is 6.022 into 10 power 23 particles, molecules are, what is that? Atoms. This is your what is that? Mole concept, right? To understand this mole concept, there should be a presence of this Avogadro number or the Avogadro constant. Nothing but 1 mole. Now 1 mole equals 6.022 into 10 power 23 atoms or the molecules. Now I am going to write that one. What is the conclusion for this? Now look at this one. After all these things, we got to answer that 1 mole equals 6.022 into 10 power 23 atoms of the molecules. When any reactants, they are going to combine to form a compound, to form any product, then how many moles that are required? For example, you take any simply, now we have taken H2 and O2. These two are the reactants and H2 is the product. And here it requires two molecules of the hydrogen and the one molecule of the oxygen that combines to form a two molecules of the water. Like that, we have to know how many molecules of the reactant side required to form this number of molecules of the product. For that reason, we are going to use the word called mole. Right? In that, 1 mole equals to 6.022 into 10 power 23 atoms. Then, in textbook they are given some numericals, some problems based on this one to find out the number of moles. How many number of moles are required to form that particular product. Now, look at here. I am going to simply write some abbreviations. Here I am going to write N. Small n is nothing but number of moles. Number of moles. Right? And I am simply write M. M is nothing but given mass. Given mass. For example, 5 gram, 10 gram of any chemical, so and so chemical, then that is small m. Then I am going to write the capital M. This is molar mass. Right? And now I am going to write N. This is number of molecules or atoms. And now I am going to write the Avogadro constant or number constant. This is they are given in the textbook. Avogadro number of the Avogadro constant. By taking all these abbreviations, now I am going to finally write a simple formula for this. Number of moles required to form a particular compound or a product is M by M. That equals N by N. This is a simple formula to calculate the number of moles that are required to form the particular compound. Now I keep it in mind. I am going to repeat. N equals to small m by m. That equals capital N by N. This is they are given in your textbook. By using this one, we are going to calculate the numerical.